Welcome.
Hello, everyone.
Hello, Mahmoud. Hello. Oh, Barai. Hello. So, One Labs exploration team is here as well.
Yes.
Yes. Right. Again, you weren't here. Mina NFT already reached 620 users. Barai, Mahmoud, and all. Want to celebrate it. Yeah. Growing nice. All right. Then stage is for zkCloudWorker.
Okay, thank you. Let me share my screen. Okay. Can you see now the screen?
Yes, you see it.
Perfect. Okay. Welcome to zkCloudWorker. It's a cloud proving service for Mina protocol mainnet. It's in the category of ZK Infra, and as you see, now there are two projects on the mainnet. It's O1JS and zkCloudWorker. The mission of zkCloudWorker is to make user experience on the mainnet as easy and pleasant as possible by moving all the computations that can be moved from the front end to the cloud and handle all those computations. As of now, zkCloudWorker holds 90% market share in its segment. That is out of 10 transactions, ZK app transactions initiated by the users in the wallet on mainnet. 9 transactions are being handled and proved by the zkCloudWorker. It's what the users of zkCloudWorker are saying, that it was quite smooth experience buying NFTs with zkCloudWorker. And it's basically why we created this project. And now we have several integrations. There is integration with Mina NFT on mainnet and DevNet. There is integration with Mina domain name service with social caps. And basically, like 1,000 transactions are already sent on all networks using those integrations. If we go briefly what zkCloudWorker is, what parts are made. It's AWS Cloud, where we have workers for calculating proofs, sending transactions. We have storage for developer repos, for prover keys, for files, key value storage, for metadata storage. The second part is library that is being used to interact with zkCloudWorker. Common client interface tool that allows for easy deployment of the repo to the cloud and also responsible for the verification of the contract. There is site that helps work with it, and there are nuts and Celestia nodes that also help to do some stuff on zkCloudWorker. So let's basically look now how the transactions are being made on zkCloudWorker. So let's start just by trying to make a transaction on mainnet. So let's say I want to send transaction by increasing the price of the NFT. So I press button sell. I say that, okay, I want to set 75 minutes the price, and I'm pressing the sell button. So what's going on now? The first, the library is being loaded. Then I fetch information from the mainnet, and then I sign the transaction. As soon as user signature is received, the cloud proving job is being started. So If we look at the real-time panel for all the jobs, we see that we have started job that sells NFT, and it's basically the same job that I just started. And we can see all the status. It will be changed later to finished and used, as we've seen it for the previous jobs. And as soon as this job will be finished, it will be transaction on mainnet that will be sent and included into the block. So let's look in the detail, basically how it's working. So what's going on from front-end? I should say that basically what I described now, it's specifically for mainnet, because on DevNet you can have the similar workflow, but not exactly the same as on mainnet. So we're speaking now about the mainnet workflow. The first what is being done is async loading of ONJS, for the reason that when you load your front end, you don't need to fetch 100 megabytes of ONJS. So the library is being fetched only on demand when we really want to make transactions. The next step is account state being fetched from the several sources. The first is standard GraphQL request, and it also contains nonce. The second, two sources from BlockBerry API. The first source is all payment transactions for the sender public key, and the second source is all ZKI transactions. Then basically we have three nonces from three sources, and we need to find the maximum nonce that is, can be used. Why we need it? Because people tend, according to my experience, to send many transactions within a short period. So by the time you start the transaction, probably there are already many transactions that are sent by the same key. And if you go to the Explorer, you can see that there are cases when people are sending many transactions. So I selected now, for example, 4 transactions that went into the same block right now from the same public key. And the reason why it was able to do so is because the mini NFT contract is stateless, and because the nonce handling take into account all the pending transactions. It's why it's important to use BlockBerry API for the user experience. And of course, we need to check the sender balance to make sure that it's enough to make the transaction. The next step, we're preparing transaction on front end and serializing it. There is no contract compiling or proving at this stage. So we don't need to spend time on compilation or proving on front end, and it's very, very fast, as you see. The next is signing the transaction with send transaction with only sign option, and sending serialized transaction and to zkCloudWorker that actually do all the stuff. Meantime, we have the process finished, so we can see now on Mini Explorer pending transaction that is selling this NFT. And we can see if we want all the details of this job on zkCloudWorker side together with metadata. So zkCloudWorker allows to add specific metadata for every transaction, and it can be used by any explorer that is showing those transactions on any network. So here we have mainnet transaction, we have all the details, and we can also click on the ID here to open the same transaction details for this transaction. Okay, let me return to workflow. So basically, when we go to zkCloudWorker, first the repo that is responsible for handling of the transaction is being loaded from the AFS, so that's very fast. The second, the contract is being compiled using the existing Prover's fees cache, also in AFS. The fetching account state this time only using GraphQL because we don't need to change the nodes, it already exists, and we just use the nodes from the serialized transaction. We deserialize a transaction, creating a new one with the same data, deserialized signature authorization and binding values. Then we're proving this transaction. So basically all the compilation and proving is on zkCloudWorker. We're sending it to mainnet, publishing transaction metadata that can be seen later in Explorer, calculating billing information, publishing the job result on NUTS and Algolia, and returning the transaction hash to frontend so it can be shown to the user. And when we looking at various information, we see that here it's updated using NUT. By the way, I see a new job. Someone decided to buy NFT, and this job just started. And it was in parallel with the job. So it's yes, finished and used. So you see how it's working real time. Okay, great. So let me briefly go now to the various parts. So we have cloud with 10 gigabytes of memory workers and 6 processors each. We have library with different APIs. And this API allows to save data and get data by case. So we have key value store, we have file store. It's possible to add tasks and process them. So in case you need to do something every 5 minutes, it's possible. It's possible to send L2 transactions and process them in case you do in your lab. We provide deployers for the testnet, so you can test your codes using private keys, pre-funded on testnet. On mainnet, we do not provide this and do not plan to keep mainnet private keys on zkCloudWorker. You can execute proofs, including calculate proofs, including recursive proofs. So you can send like many transactions. They will be calculated proofs and they will be merged. On zkCloudWorker, you can publish metadata. You can encrypt and decrypt the data using KMS, getting job results. And in case you got problems with O1JS WASM being unstable, you can force worker restart to start it from the scratch to make sure that you continue to do it. For command line interface tool, basically it's for deployment. So you can just say deploy, and the deployment will be completed in approximately 1 minute. So for example, for mini NFT, it takes 52 seconds to deploy the mint worker to the cloud. And we have zkCloudWorker site. Mario, could you please tell a little bit about the site and show it?
Yes, thank you. Let me go share now. And okay. Yes, this is the site. This is the application that you can use to manage your account in the CloudWorker. So you can start by doing login here. You need to log in using your account. Okay. You need a Min account to be logged in, and you see here that it shows your balance here, how much of the amount of money you have consumed here. You can also do some top up here. I will not do it and pay this in case your balance has gone below a certain value. And now I will show you, not with my account, but with Mikhail account here, because he has more jobs. Then you can, well, you can browse here. You can browse all the workers you have deployed here, workers deployed by you, or that you have others have deployed but you are using. For example, if you go to the Mint worker here, then it will show you all the jobs which are related to the Mint worker, and by clicking here you can show all the details of the worker, of the job, including the going to the transaction in the Mina scan, or to the account who has been working on this job. Okay, you can also have my jobs, which are jobs which have been sent by you and filtered by who deployed these ones, or deployed by other people. You can also search jobs here, and you can have also the Explorer here, which is to search all jobs that are being used in the zkCloudWorker by other people, not your jobs. And you can also filter here. For example, if you want the means here, you can filter under the means, and you can, for example, see Jose here. Okay. Then you can filter here by this. You also have the billing here, which shows all the jobs which you have been doing, and how much build time it costed you, and how much in Mina it had costed you. You can see that it's just a very low price you are paying for this, and well, mostly it's this one. And as I said before, you can top up from here. And as I think Mikhail will continue. Do you have something more for me to show you, Mikhail? It's okay for this, or do you?
No. I think we already on time, so we have 20 minutes for presentation and some more minutes to answer the question. So the first question is: do workers generate proofs on the user behalf? Yes. So basically, the user send transactions, and then we generate the proof for the user, or in case the developer want to use it as the backend, it's for the developer. And in terms of the privacy, you can use encryption, and Mario can give more details on encryption. And if you go into the documentation on our site, you can see quite extensive information of the encryption that is possible. And also there are methods where you can basically prepare some part that is confidential on front end, and then send only to Merkle tree root to the backend. It's, by the way, what's going on with Mina NFT. When the private keys are being included there, they are not sent for the Mint operation. They are handled fully on the user computer and not used in zkCloudWorker. So zkCloudWorker don't even receive those keys. Okay, so basically it's all what we wanted to do it. There were some examples that we covered during the midpoint presentations. And this time we decided to concentrate on more complicated workflow specific for mainnet, because after the hard fork, we think it's most important part of it. No encryption. The next question: does encryption increase proving time in that scenario? I would say almost not, because in one of examples that exist on encryption, we use NATs to communicate the encrypted data, and NATs it's very, very fast compared to the proving time. So I would say it may be by 1 second increase or something like this. So it's not important. And in terms of using front ends for the, okay, you need in this workflow to load OpenJS library anyway, and it's the longest time because it's like 100 megabytes. And then as soon as you have OpenJS library, all the calculations are quite fast. So maybe it's another second for calculating of the small Merkle tree root. In case you want to calculate Merkle tree root for a file, yes, it can be quite significant. It can be something like 10 seconds, 15 seconds for big files. And it can be significant delays. There are some ways to make it faster. And you can go, for example, to min-nft library to find the fast Merkle tree root calculation that are being used. But in general, I would say it's like 1 second, maybe 2 seconds increase in the time. So it's, I would say it's not critical. I'm just wondering if the CloudWorker doesn't prove the correct proof. Is there any way to detect that? Yes, of course. So basically, the proof that is being calculated based on the information provided. So what you can do, you can go to the min NFT. You can mint an NFT with private data, then prepare the proof and verify the proof, and you will see the proof will be prepared and verified. And then you can change this proof file and change just one symbol there, for example, and try to verify, and you see that it will not be verified. Or you can change the information in the private data that being proved. So you can take the JSON file with private NFT data, you can change one symbol there of the key that you're proving and generate the proof. And with some probability you will be able to generate the proof. Also, there are some checks that prevent it, but of course you can find a way to generate the proof, but then it will not be verified. Because when the proof is being verified, it's verified first that it's valid, and the second, it's verified against the account state on the mina. And here you will not be able to do it. So basically, in any way, when you will try to change all the original data or change the proof, and you will try to verify the proof later, it will not be possible to get verification successful. It will fail. How much work is needed to deploy CloudWorkers? So basically, what you need to do is you need to change a little bit your wrapper to add one function called zkCloudWorker, and there are some examples how to do it. Then you need to install Command Client Interface tool, and you need to run zkCloudWorker deploy. Command that will take something like 1 minute. So for a simple case, I would say that within 1 hour you can make everything quite easily. For more complicated cases, when you have a lot of contracts and so on, probably you will need something like 1 day, and you have many examples in our GitHub that you can use, and of course we can help to do it, no problem with it. Okay, Mario.
Yeah, I wanted to mention that it's important that you have your contract and your previously tested, because if you deploy a non-tested contract, you will have uh, a lot of time, because you deploy and something fails and you have to look at the logo. So it's important to have it very well tested before you are going to do the deploy, and you just do the deploy, and you are certain that you are deploying something which is already working, because otherwise it will take some time to go back and forward before your code, and so I think that's important to do it. Okay.
Yes, and we have local cloud working, especially for debugging. And you can see examples how you can use it. So basically, you can start using local cloud worker without the cloud. So everything will be on your computer. You will see if it's working or not, what kind of the problems, bugs, error messages do you receive. And as soon as everything is fine, you actually deploy it to the cloud. So it's of course it's not made for production environment. The local cloud, it's simply for the debugging, for the enhanced developer experience. And regarding the question, what if the proof will be not what the user asks? Okay, it's again will not be verified in this case. And given that user signs the transaction with the data, and there are some account updates that's signed by the user, and you just proving this transaction, or in case you use ZK program and you create some recursive proof, you have public inputs or public outputs that should be matched with some preconditions in account updates. So basically, it's your role as developer to make sure that you have all the preconditions that are being checked during the transaction being included into the block, and make sure that everything is matching in a right way. So it's developer responsibility, and user is signing the transaction that is basically created on front end, and then it's sent to the zkCloudWorker just for proving. The next question, can someone deploy malicious workers to forward interactions? Yes, of course. You can always have malicious workers and malicious contracts. So it's why we have verification of the contracts. So what is possible to do? It's possible to call the zkCloudWorker verify. And what is the procedure then? Then the repo is being zipped, sent to the cloud. Then the zkCloudWorker install all the node models. So node models are not included, and they're being fetched fresh, so they cannot be changed. And then the smart contract is compiled. Verification key is received and compared with the verification key on the network. And metadata is created that is available for all the explorers. And basically, there are two files of this metadata. The first file is a JSON file that shows all the verification keys and the account public key provided by the developer. And the second file is a zip file with the code. So any explorer can basically compare the verification key on this file with what is on the state of the contract, because as you understand, the verification key can be changed later. So before relying on the code of the contract, it's necessary to make sure that it's the same contract that was used to receive the verification key on account state. And then you have the contract code that you actually use, so you can verify it. Of course, it's a big question how you will read it, because it's more like professional task, but at least you have this possibility with zkCloudWorker. Okay, we have our time finished, so thank you everyone for attention, and in case you have any questions, please visit our site, please look at our examples, please contact us on Discord. We will be happy to onboard everyone to our project and to use zkCloudWorker. Thank you everyone.
Thank you as well, the CloudWorker team, and also thanks for answering the questions. I also appreciate our audience being very active in the chat, asking questions. That's really good to hear. Okay, so let me stop this recording and start